Hello dear friends, this is Mahendra Jakkulwar and once again welcome to my YouTube channel. Dear friends, in this video we are going to learn the new concept, that is latent heat. Friends, the word latent means hidden. So to understand this concept, that is latent heat, we have to see the activity which is given in your textbook. Before starting this activity, I request you all, please subscribe the channel and press the bell icon to get notification of new videos. So let's start the activity. The experimental arrangement is as shown in the figure. Let us consider we have taken ice at -3 degrees Celsius. When we start the burner, then the temperature of ice increases from -3 degrees Celsius to 0 degrees Celsius. And once the temperature of ice reaches to the 0 degrees Celsius, then on further heating, the temperature of ice does not increases for some time. During this time, the temperature of ice remains constant at 0 degrees Celsius. And once all the ice get converted into water, then the temperature of water increases up to 100 degrees Celsius. And again, once the temperature of water reaches the 100 degrees Celsius, then the temperature will remain constant till all the water get converted into water vapors. Dear friends, during this experiment, we get constant temperature during the conversion of solid into liquid and liquid into gases. That is, ice into water and water into water vapors. During this conversion, the temperature of the water does not increases, but we are continuously supplying the heat. Now the question is, where does this heat go? Even though we are supplying the heat continuously, but the temperature remains constant. In the first stage, the temperature remains constant at 0 degrees Celsius, and in the second stage, the temperature remains constant at 100 degrees Celsius. When we heat the ice, its temperature will be increases up to 0 degrees Celsius. At point B, we get ice at 0 degrees Celsius. On further heating from B to C, the temperature of the ice does not increases. It will remains at 0 degrees Celsius. Then where does this heat go? This is the question. And once the all ices get converted into water, now the temperature of water will increases from 0 degrees Celsius to 100 degrees Celsius. The graph CD indicates that the temperature of water increases from 0 degrees Celsius to 100 degrees Celsius. And once the temperature of water reaches to 100 degrees Celsius at point D, then on further heating, the temperature of water does not increases. It will remains constant at 100 degrees Celsius. In figure, the graph DE represent the constant temperature at 100 degrees Celsius. And once all the water get converted into gases or its vapor, then its temperature will be increases. That is represented by graph EF. At BC and DE, the temperature remains constant. Now the question is, we are supplying the heat, but the temperature is not increasing. Then where does this heat go? The answer is, during these two phases, that is conversion of solid into liquid and liquid into gases, the heat which we are supplying, that is utilized to convert the solid into liquid, and in second stage, the heat is utilized to convert the liquid into gaseous stage. At these two stages, during the conversion of solid into liquid and liquid into gases, the amount of heat energy which is absorbed by the system is utilized to convert the state, that is solid into liquid and liquid into gases. So this heat is called as latent heat. So what is latent heat? Latent heat is the heat energy absorbed by the material during the conversion of a state at constant temperature. But we know that the process of conversion of solid into liquid on heating is called as melting, and the process of conversion of liquid into gases is called as vaporization. So here two latent heat are given. The first latent heat is latent heat of melting, or second latent heat is latent heat of vaporization. The melting is also known as fusion. Therefore, we call it latent heat of fusion. And the second one is latent heat of vaporization. So, what is the definition of latent heat of fusion? The amount of heat energy required to change solid into liquid at atmospheric pressure at its melting point without a rise in temperature. And the second one is latent heat of vaporization. So how can we define the latent heat of vaporization? The amount of heat energy required to change liquid into gases at atmospheric pressure at its boiling point without a rise in temperature. Here in both of the definition, the word atmospheric pressure is very important, because if the pressure of atmosphere, that is atmospheric pressure, changes, then amount of heat energy absorbed during this conversion, that is solid into liquid or liquid into gases, will also change. So what is latent heat of fusion? The amount of heat energy absorbed during the conversion of solid into liquid at atmospheric pressure at its boiling point without a rise in temperature. And what is the definition of latent heat of vaporization? The latent heat of vaporization is defined as the amount of heat energy required to change liquid into gases at atmospheric pressure at its boiling point without a rise in temperature. And the next concept is specific latent heat. There is a little bit difference between the latent heat and specific latent heat. What is meant by the specific latent heat? Specific latent heat gives a specific information. That is, specific latent heat is defined as the amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid state. And the second definition is specific latent heat of vaporization. And the specific latent heat of vaporization can be defined as the amount of heat energy absorbed at constant temperature during the conversion of liquid state into gaseous state. These two definitions are very important. The first definition is specific latent heat of fusion. Fusion means melting. The amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid state. And the second one is the amount of heat energy absorbed at constant temperature by unit mass of a liquid to convert into gaseous state. So how much heat energy is required to convert 1 gram of ice into 1 gram of water? To convert 1 gram of ice into 1 gram of water, we require 80 calories energy. And the specific latent heat of vaporization of water is 540 calories per gram. This means that to convert 1 gram of water into 1 gram of vapors, we need 540 calories heat energy. So this is all about specific latent heat of fusion and vaporization. Is the concept of latent heat is applicable during the transformation of gaseous phase into liquid phase and liquid phase into solid phase? The answer is yes. The concept of latent heat is applicable during the conversion of gaseous phase into liquid phase and liquid phase into solid phase. We know that the conversion of gases into liquid is known as condensation, and the conversion of liquid into solid is known as freezing. So the concept of latent heat is applicable during this conversion. So the amount of heat energy absorbed during the conversion of solid into liquid is equal to amount of heat energy released during the conversion of liquid into solid. This means that the latent heat of melting and the latent heat of freezing both are equal. And the second question is, where does this latent heat goes during the transformation of phases? This heat energy is utilized to weakening the bonds between the solid molecules to convert it into liquid phase. And during vaporization, the latent heat of vaporization is utilized to weakening the bonds between liquid molecules to convert into gaseous state. This means that the latent heat is utilized to weakening the bonds between the molecules or to overcome the intermolecular force of attraction. So dear friends, this is all about the latent heat and the specific latent heat of melting, that is fusion and vaporization. Hope you understand this concept. If you enjoy this video, then please hit a like, subscribe the channel and don't forget to press the bell icon. Dear friends, see you soon in next videos. Till then, bye bye and take care.